Okay. So we had seen last time internal direct product and external direct product. And છેલ્લે જે idea હતો એના ઉપરથી we are discussing that they will be isomorphic. So let us try that. Right? What was external direct product and internal direct product? So we denote by the same notation. પેલું A bar કરતા હતા ને, we will not denote by G bar, GI bar. We'll use the same notation. So let G be a group and suppose that G is internal direct product. Let G be a group and suppose that G is internal direct product of N1 and 2. As soon as we say that internal direct product of this, it is understood that these are all normal subgroups. If you recall the definition, they are normal subgroups of G. They are subgroups. And let us call T as external direct product. T equals to let us say N1 cross N2 cross N and N. Right? So suppose T is this external direct product. We started with T. આપણે આવું લેતા હતા external direct product first start કર્યું, and then how do we take internal direct product? Like this, N1 bar, N2 bar, but we'll not denote by N1 bar, N2 bar, and so on. We just denote by N1. પહેલા અમે A bar લેતા હતા. It is understood whenever it is considered as internal direct product, we consider A as A bar because they are isomorphic. And if we consider external direct product, we consider B. So like this. Then what we have to show? We have to show that then G is isomorphic to T. This is what we are going to prove today. So let us define a map from T to G. Define psi from T to G. How do we define? By? Yes. Any idea? Psi of what should be what? Okay, define કરશું. કોઈ નહીં? No hands raised. તો મારી રીતે પૂછું, બધાને આવડે છે? Yes, Nitish.
Hello, sir.
Can you see the screen?
Yes, sir.
T is external direct product and G is internal direct product. You want to define a map. So આનો element કેવો હોય? T નો element કેવી રીતે લાગશે? How it will look like?
Yes, sir. No idea. Vehicle revision નથી થયું ને એટલે.
Okay. Yeah. Okay. 3 જણા છે. Yes, Amisha. Okay, tell.
Yes, sir.
હા.
T માંથી coordinate લેવાના A1, A2 up to dash AN.
Okay.
N1 માં is equal
external
to
direct an equals to
A1 A2 up to an product.
એની G ની definition છે, right? Internal direct product.
હા.
What is the definition of internal direct product? Okay, G is a product of this N1 and 2 product NN. And not only that, every element for all G in G, G can be uniquely written as all G in G. G can be uniquely written as. This is definition of internal direct product, uniquely written as G equals to, if you remember, I would like to do M1 up to Mn, where Mi belongs to Ni. Right? This is the definition of internal direct product. So we have to define. So as soon as we have element Ai belongs to Ni, so we can take product A1, A2, and 2, An. Okay, so this is an element of G where is Ai? Ai is in Ni. I equals to 1, 2, up to N. Okay, so this is how we have defined. Now we have to show that psi is onto. First, show that psi is, let us start with easy one, onto. Hey Jay, raise your hand. Those who are done. Onto, so by definition માંથી clear છે. જે લોકોને onto થઈ જાય કે try one more. Function તો બતાવી દીધું છે ને, one onto જ use કરવાનું. You have to just use the definition. મહેનત કરજો હો બધાય. પરીક્ષા લક્ષી ના ભણો બધાય. Yes, ચિરાગ, onto થઈ ગયું તો one prove કરો. Definition તો even મેં લખી દીધી છે. It is on your screen. External direct product તો તમને ખ્યાલ જ છે. What is external direct product? Is tuples and tuples, element coming from each coordinate coming from this group Ni. And you know કેવી રીતે product થાય. કાલે આપણે જોયું G1 G2 Gn, G1 dash up to Gn dash. So it multiplies with G1 G1 dash, comma G2 G2 dash, and so on. External direct product, you know, internal direct product definition I have written on the screen. You can see there are two conditions satisfied. One is G is the product of all these groups. કાલે આપણે કર્યું ને A bar B bar product માં લખાય. So that is one thing. And another is that every element can be uniquely written as this. Yes, Mitiksha. Onto માં શું કરશું? Onto is clear to everybody, even if nobody knows what is this. Yes, once you take an element in G, તો કેવો હશે? કયા ફોર્મમાં હશે? Yes,
યસ
Mitiksha.
હા, તો આપણે કોઈ એલિમેન્ટ લઈએ કે જે G માં હોય તો ઈ આપણને શું આપશે? તો કે ઈ A1 A2 A3 up to AN એવા ટર્મમાં આવશે.
Let Y belongs to G, but G is internal direct product. Yes, because
Yes.
G is given to be internal direct product, and T આપણે લીધું છે external direct product. So Y can be, since G is internal direct product. તો કેવું થાય? Y can be written as, Y can be uniquely written as, uniquely થશે. Y can be uniquely, see the definition, uniquely written as, કેવી રીતે લખાશે? Yes, Mitiksha.
યસ, આપણે એવી રીતે લખી શકીએ A1 A2 A3 up to AN ના ટર્મમાં.
Yeah, A1 A2 up to AN, where AI is in NI. બરાબર? Okay, so આ મળે તો એ મળે X, then
હા,
yeah,
then
take
હવે
X equals to, શું લેશું X?
હા, then આપણે A1 A2 A3 up to AN.
Yes, we can take a tuple like
હા,
this.
ઈ હા
and this
એ
is an
ટી માં
element of
એક્ઝિસ્ટ
T.
કરે છે.
It is T, and what is psi of x? Psi of x is nothing but psi of a1, a2 up to an, and એવી જ રીતે define કર્યું છે. This is nothing but the product a1, a2, an, and the product is an element of this is y. This is an element of G. So psi is on 2. Okay. Next, let us show that psi is 1. Yes, Ketan, nice. બોલો.
psi 1 બતાવવા માટે psi of a1 a2 up to an coordinate માં લેવાનું is equal to psi of b1 b2 up to bn.
Okay, so let a1, a2, an, and another element we take b1, b2
Up
up to
bn.
bn. Yeah, આ બંને આપણે t માંથી લીધા. Yes.
પછી psi apply કરે એટલે psi of
Yes, so then psi of a1. Okay, try તો કરી શકો ને, અટકો એનો વાંધો નહીં. Try તો કરો, try જ ના કરો ને
is
ખાલી
equal
બેઠા
to
બેઠા જુઓ.
psi of b1 b2 up
લેક્ચર
to
આપશે. Yeah.
and
બધા
psi of
પાછું
a1
ભણાવો.
b2 up to
Yeah, so this implies
an is equal to a1 a2 up to an product b1 b2 up to bn.
yes. Okay.
બંને સરખું થઈ ગયેલું 1 1 થઈ.
ના શું સરખું? આપણે તો આ બતાવવાનું ને, આ બે એલિમેન્ટ સરખા છે. હા. You have to show that આ બંને એલિમેન્ટ સરખા છે. એલિમેન્ટ કે છે સરખા બધા? આ તો પ્રોડક્ટ સરખા છે. મલ્ટિપ્લિકેશન સરખું. એલિમેન્ટ સરખા નથી થયા હજી તો. કોમા વાળું બતાવો ને, કોમા કરીને સરખું થાય. એ તો જો 6 તો 1 into 6 એ આવે અને 2 into 3 એ આવે. 2,3 ને 1,6 સરખું નથી. હે ને? જો આ તો પ્રોડક્ટ સરખો છે. આ કેવું થયું? 1,6 અને અહીં આવે 2,3. આ સરખું નથી, પણ આપણે 6 લખવું છે 1 into 6. This is same as 2 into 3. પ્રોડક્ટ સરખો થાય છે, પણ ઓલો એલિમેન્ટ સરખો નથી. એ કંઈક લાવવું પડશે, ક્યાંક તો યુઝ કરવું પડશે. કંઈક તો શું આપ્યું છે? કઈ વસ્તુ આપી છે ક્વેશ્ચનમાં? યસ, બટ ગુડ ધેટ યુ ટ્રાય. આ વસ્તુ છે જરૂરી. ઓકે, હવે અહીંયા ઘણા લોકો ટ્રાય કરે છે. યસ, વૈશાલી.
Yes, sir. AI equal to BI for I equal to 1 to up to n.
હા, બસ એ શું કામ? વાય ધેટ ઇફ ધેટ વી કેન ડુ ધેન વી આર ડન. આના ઉપરથી એવું કહી દેવાય કે ઇફ AI equals to BI, તમે કીધું એ લખું છું, આઈ એમ રાઇટિંગ ઇટ હિયર. So she said AI equals to BI for all I equals to 1 to up to I equals to 1 to up to n. અને જો if this is done, then if અહીંયા question mark છે, આવું શું કામ? If this is done, then if a1 comma a2 up to an, this is nothing but this is equals to b1 comma b2 up to bn. हाँ, तो आ लखी सके because a1 equals to b1, then we are done. And this implies thus I can say that the psi is 1 1. हमारा question पहलो હતો કે if 1 into 6 equals to 2 into 3, how can we say that this 1 equals to 2 અને એ product સરખો થાય? So why AI equals to BI? Yes, Vrunda.
Yes, sir. Yes, sir. G internal direct product છે તો આપણે એના દરેક એલિમેન્ટને યુનિકલી લખી શકીશું. તો
Exactly.
આપણે હા એટલા માટે AI is equal to BI કહી શકીએ.
So see what it says. G is internal direct product. Every element can be uniquely written as a product of. So every G in G can be uniquely written as a product of this, where the elements M1. So first element coming from N1, second element coming from N2, third element coming from Nn. So such an expression is unique, so that Mi is in AI. So આમાં શું થશે? What we have here we have, or let it be, then I can add one more space here. Yes, and I can say that since, or here we can write AI belongs to Ni, and BI also belongs to Ni. Right? So since G is internal direct product, yes, હવે માઇક ઓફ કરી દો. કોનું છે ચાલુ? સારું બેકગ્રાઉન્ડ મ્યુઝિક મૂકો, ખડખડ ના કરો. એટલે વળી is it clear? So G is internal direct product. યાર ઇન્દ્ર સિંહ ગયા વખતે હેરાન કરતો હતો. ક્લાસમાં શાંત શાંત બેસે, આમાં જ ડિસ્ટર્બ કરે. આમાં એક ફાયદો થયો, ઓલા ક્લાસમાં અવાજ કરતા હોય એમાં શાંતિથી બેઠા હોય, પણ ઘણા એવા હોય કે ક્લાસમાં શાંતિથી બેઠા હોય, આમાં કંઈક લઈને આવે નવું. Okay, yeah. So since G is internal direct product, the expression is unique. Is it clear? And therefore we can say that क्योंकि first element A1 from N1, second A2 from N2, third A3 from N3, and so on, AN from Nn. આવું તો expression unique જ હોય. So if these two are equal, so then they must be equal. So each individual element are equal. So this is true. And if AI equals to BI, then this is 1. Is it clear? What we use the fact that G is internal direct product. In the definition use करें, property of that G is internal direct product. Such an expression is unique. This is what we used. Okay, so I proceed. હવે શું બાકી રહ્યું isomorphic માં તો બતાવવા માટે? We need homomorphism. All right. So last step. આ હોમોમોર્ફિઝમ થાય, બધા મેપ હોમોમોર્ફિઝમ થાય એવું જરૂર નથી, બધા મેપ આઇસોમોર્ફિક થાય એવું જરૂર નથી. There is one homomorphism at least. Okay, show that size homomorphism. જે લોકોને થઈ જાય, you can raise your hand. If you want to see how size is defined, it is defined like this. Once this is done, we can say that internal direct product is isomorphic to external direct product. And as we did in vector space, we just say direction. We don't say internal direction, we don't say external direction. So here also we will say direction. Whenever we want to use internal expression, we can use internal expression. Whenever we want to use external expression, we can use external expression. So just direct product is sufficient. So yeah, show that psi is a homomorphism. Right? If you are done, raise your hand. If you have tried. સાચું ખોટું ચલો આમાં જોશું. મેં ક્યાં કેતન પાસેથી પૈસા લીધા એક? Wow. Yes, so many people. I like it. Very nice. Excellent. Last 15 seconds. Anybody wants to raise hand? Ten, 9. Okay, last 6.5 seconds. છેલ્લી 3.5 સેકન્ડ બાકી છે. કોઈ થઈ જાય તો થોડીક આઈડિયા આવે તો raise your hand. Okay, yeah, so time is up. Let us ask someone. કોને પૂછું? હવે તો અઘરું થઈ ગયું. ચલો કોને? ચિરાગ છે. Yeah, let us ask Chirag. Yes, Chirag, tell. Where do I
Yes, sir.
start?
બે એલિમેન્ટ લઈએ આપણે ટી માંથી.
આ હોમોમોર્ફિઝમ નથી લખ્યું, આને કંઈક બીજું લખ્યું છે. હા, હવે બરાબર. યસ.
સર કોઈ પણ બે એલિમેન્ટ લઈએ આપણે ટી માંથી. A1 A2
yes, A1 A2 AN.
Yes.
અને yes, B1 B2 up to
B2
BN.
up to BN.
Okay.
હવે આપણે સાઈ એપ્લાય કરશું આ બંને એલિમેન્ટ પર.
Okay,
બંને
so
એલિમેન્ટ પ્રોડક્ટ.
if you want good notation, then let us call it this as X, and let us call this as capital Y. So we use this notation just for simplicity. So psi of xy. We have to show psi of xy equals to psi of x, psi of y. Okay, so psi of xy equals to psi of I write x first. So A1, A2, AN, and y I can write as B1, B2, and
BN.
okay, yes, bracket closed. And then what is this, right? ઘણા તો ડાયરેક્ટ લખી નાખે. એનું જેમ હાલતું હોય ને મેથેમેટિક્સમાં એને બનાવ્યું હોય ને મેથેમેટિક્સ એમ ઘણા તો સીધું આમ જ લખી નાખે. Yes, some people write like this as if they own mathematics. They are the creator of mathematics. Einstein, Newton બધા શરમાઈ જાય. Oh, therefore this is that. No, not like this. This is wrong. Yeah, શું લખશું?
Psi
So,
of A1 B1.
Yeah, first operate here, right? Directly we cannot apply. So first operate this element. So what will be this element? Direct product. It is external direct product. So external direct product, we know how it is being taken. So this element coordinate wise product is taken. So A1 B1, A2 B2, and AN BN. Okay, so this is an element, and now we know if we have an n tuple, how do we apply psi?
સર હવે A1 B1 into A2 B2 up to રીતે કરી દેવાનું.
Yeah, A1 B1. I'm writing થોડીક space. I am giving space in between just to make realize that how do you multiply, and then dot 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 AN BN. What do we want?
સર આ B1 ને A2 ને ઈ કમ્યુટ થઈને એવું બતાવવું પડશે.
Oh, એવું બતાવ્યું છે તમે?
નહીં સર.
Okay, let me start from here. Psi of let us start from psi x, psi y. What is psi x, psi y? So let us ask somebody else. કોને પૂછું? પ્રદીપ, તો તમે સૌથી પહેલા હાથ ઊંચો કર્યો હતો ને? So psi x, psi y is psi of A1, A2, x is A1, A2, AN. And what is psi of Y. What is Y? Y is B1, B2, Bn. Right? And what is this? A1, A2 up to An. And we have B1, B2 to Bn. If we are going reverse way. Yes, Pradeep. હવે અહીંથી અહીંયા કેવી રીતે આવશે? From this to this step, how do we come? મને અવાજ નથી આવતો પ્રદીપ. માઇક ઓન છે? બોલશો તો જ આવશે અવાજ. ત્યાં બોલવું પડે, ખાલી ઓન કરવાથી ના. એનીવે તમે બોલતા હશો, બટ સમ પ્રોબ્લેમ ઇઝ ધેર. લેટ અસ આસ્ક પ્રભાત.
સર પાકો ખ્યાલ નથી પણ નોર્મલ નો યુઝ કરવો પડશે મે બી.
નોર્મલ હોય તો કમ્યુટ થઈ જાય.
ફાઇનાઇટ અબેરન્ટ ગ્રુપ હોય તો નોર્મલ થાય.
અબેરન્ટ ગ્રુપ હોય તો બધું નોર્મલ થઈ જાય, અને તો ભાઈ કમ્યુટ થઈ જાય તો નોર્મલ ને હું કામ યુઝ કરીએ? સીધું કમ્યુટ ના કરાવી દઈએ. ઓકે, બીજા જેને હાથ ઉપર છે ને પૂછીએ. યસ નીતિશ. હા, શું કરશો? કેવી રીતે આવશે?
ઇન્ટરનલ ડાયરેક્ટ પ્રોડક્ટમાં આપણે જે ડેફિનેશન છે ને એમાં જ આપણે કીધું હતું ને કે કમ્યુટ્સ કરશે એકબીજાને.
એવું હતું? કમ્યુટ કરશે એવું ક્યાં કીધું?
B1 A2 ને A2 B1 લખી શકીએ ને.
ના, એવું નથી કીધું મેં કમ્યુટ કરશે એવું કે. આઈ હેવ નેવર સેડ ધેટ દે કમ્યુટ. સો ફાર આઈ હેવ નોટ ટોલ્ડ A અને B કમ્યુટ કરશે એવું ક્યાં કીધું? ઓકે, કરે છે એ વસ્તુ અલગ છે, બટ મેં કીધું હશે કદાચ કે આ ઓકે, જે આપણે છેલ્લે કરતા હતા ત્યારે કહેતો હતો કે આવી કંઈક જરૂર પડશે. યસ શનિ.
સર AI ઇક્વલ ટુ BI છે એનો યુઝ કરી શકીએ?
AI
ઇક્વલ ટુ BI ઇન્ટરનલ ડાયરેક્ટ પ્રોડક્ટ છે તો?
ના આ તો બે અલગ એલિમેન્ટ લીધા છે ને આપણે. ક્યાં સેમ છે એવું ક્યાં કીધું? તો ઇક્વલ ક્યારે કહી શકીએ? when these two expressions are same. These two expressions are same, then components are same. આપણે તો બે અલગ જ લીધા છે. we have taken two elements. Okay, શિલ્પા.
Yes, sir.
Yes.
ના સર, આમ આઈડિયા નથી કોઈ એવી રીતે કમ્પ્યુટ
Okay,
કરશે.
good. Okay, fine, no problem. Nikita.
યસ સર.
કેવી રીતે થશે? કમ્યુટ કરે?
ખબર નહીં.
યસ.
સર પ્રોડક્ટ છે એટલે પ્રોડક્ટમાં કમ્પ્લીટ કરવાની એટલે પ્રૂફ કરવાની જરૂર છે આમાં.
they are elements of group A, AI, BI. They are elements of G. ક્યાં આપણને a billion is not given. Yes. Anybody? પ્રેરણા, વૈશાલી, અંજના. Yes. જે નહોતું થતું ને એમાં surprisingly, which was not true, everybody raised hand. Very few people raised hand for 1, which was there. On 2 very few people, 1 or 2 or 3 people raised hand, which was there, which was true. And this is not true in general. We cannot say. And surprisingly, everybody was so excited. Okay, sir, answer આપવો છે. So everybody raised hand. Okay, so we have to prove something.
Sir.
And that is why.
Hello, sir.
Yes, Anjana. ચિરાગ એક મિનિટ આવું. હા, યસ અંજના કહે. ઓકે, હા ચિરાગ બોલો.
સર આપણે આની પહેલા પ્રૂવ કર્યું હતું પેલું નોટ સિમ્પલ વાળું બતાવતા હતા ને ત્યારે કે બે નોર્મલ સબગ્રુપ હોય ને તો એ કમ્યુટ કરે કંઈક પેલું એ બી ઇન્વર્સ ને આઈડેન્ટિટી.
ભાઈ તો ઇન્ટરસેક્શન આઈડેન્ટિટી હોય તો જ કમ્યુટ કરે. આમાં ક્યાં આપણને ખબર છે ઇન્ટરસેક્શન શું છે? ફોર એક્ઝામ્પલ ગ્રુપ. હા, બે નોર્મલ સબગ્રુપ ઇન્ટરસેક્શન આઈડેન્ટિટી હોય તો એ બી ઇન્વર્સ બી ઇન્વર્સ આપણે single time identity. Yes, Anjana, you wanted to say something? Okay, so I write here by the lemma below. So this is how I thought I would proceed. lemma theorem એવું કરાવી દે ને એમાં મજા ના આવે. So now once you do, then you realize કે આમાં ક્યાંક lemma ની જરૂર પડશે. We need to show that if there are two distinct elements, what we need, B1 A2 should commute. What we need, yeah, B1 B2 they commute. If that also we should, they are the elements of same group, right? So they commute, right? So what we need to show, what we are given. So G is internal direct product. Then we need to show that the AI is આ side લાવવાના ને. So we need to show that all AI should commute with BJ. AN should jump. It should come here. This BJs we are not showing, sequence is not breaking. See, this is B1. First is B1. Second is B2 here. Here also second is B2. So that sequence is not breaking. So we need not show this BI BJ equals to BJ BI. આની જરૂર નથી. This is not required. What we need is even AI AJ equals to AJI. That also we don't know. What we need is this AI should jump and get together. Then we can show this. Okay, so that is the lemma I'm writing. And now once we do this, then we can say that they are isomorphic. Yes, Anjana, any doubt? Your hand is raised yet? So
Sir,
yeah, tell.
sir, here G is the internal direct product of N1, N2, Nn. Here
Yeah.
N1, N2, Nn are normal, then the elements from N is our commute. So here we can write.
No, that's a mistake. This is a confusion which I was also facing when I was a student. S3 is a non-abelian group. S3 has a normal subgroup. This is this one. This is E psi and psi square. So then this is normal subgroup. But if I take any other subgroup, phi, so it has E phi. We think that this is because this is normal, it will commute with all the elements. It is not true. See, if I take an element of this and an element of this, I do not have phi psi is not equals to psi phi. Yes, they are two different elements. So even this, if I take normal subgroup, the elements of normal subgroup do not commute with elements of other groups or other elements of the group, right? So S3 is the best example. Even this E psi square is a normal subgroup. What we have, normal subgroup, we have AN equals to NA, or we have AN A inverse equals to N. This is we have. But then this does not mean that AB, where B belongs to N, equals to BA. No, this is not true. Yes, the cosets are same. As I said, they are same, but the elements do not commute. I mean, some AB will give rise to some B1, A1, and they will be equal. But we cannot say AB and B, A and B commutes. So that is the best example in S3. You can consider about the subgroup generated by psi that has order 3 and it is normal. You can check it is normal for all x psi x inverse that belongs to the subgroup generated, either it will be E psi square. But it does not commute. It is highly non-commutative. Center is only just identity element. So you can try that. I hope that will clear your doubt. And if there is difficulty, we will discuss again later. So let G be internal direct product of N1, N2. So these are all normal subgroups, N. Then what we need to show is Ni intersection Nj is identity. Chirag. Be a normal subgroup. Once you show this,
Yes,
then
sir.
you are done. Ni intersection is identity when I is not equals to J, and show that and AB equals to BA for all A in Ni and B in Nj. Yes, so two elements, if they are from different components, yeah, they commute. So here B1 is in N1 and A2 is in where? A2 is in N2. And so by this result, by this lemma, we can say that B1 A2 equals to A2 B1. So they commute. So this is how all these people will jump with each other. So right? So here will be A3 and B3. We are not commuting A to B2, so we'll commute this B2 and A3. They will jump because B2 belongs to N2 and A3 belongs to N3. So they will commute. So B2 will come on the right side, A3 will go on the left side. That is how all those AIs will collect and those BIs will be left on the right side. Then we are done. So we prove this. And this lemma is very easy. But if I had given this lemma first, so we would not have appreciated this. But the thing is that we try this and we understand where is the problem. આપણે ઘણા લોકોને જે લોકો હાથ ઊંચા કર્યા હતા એ લોકોને ખ્યાલ પણ ના આવ્યો. So many of you did not realize that this is some problem is there. We need to prove something. Yeah, we need to prove this. And the proof is very easy. Just I'll take 2 minutes more maybe if required. અત્યારે 6 મિનિટ જેવું છે. Okay, 7 મિનિટ જેવું. Yes. So how do we prove this? Any idea? કેવું રીતે બતાવશું? How do we prove that NI intersection NJ is identity? Yes, Chirag?
સર પેલા એના ઇન્ટરસેક્શન એનજી માંથી એક એલિમેન્ટ લઈએ અને એના આઈડેન્ટિટી બતાવી.
Yes, so yes, the natural way to start is that let x belongs to yes, let x belongs to Ni intersection Nj. So then we show that x equals to identity. So x is in Ni. So how do we write x as an element of? So this implies x belongs to Ni and x belongs to Nj. Now how do we write this as an element of G? G, what is G? G is internal direct product is given. So element of G can be written like this, N, right? Like this. If I want to write this as an element of G, I can write then x belongs to this. Ni means it is subset of G. And Nj also, that means it's subset of G. So x belongs to G. If x belongs to G, I want to write as product of this. So if I write this as product of elements of N1, N2, Nn, but considering x is in Ni, so then x I can write as N1 mathi I'll take E, and then again E, and so I'm writing E1, E2, EI minus 1. E1, E2, EI minus 1. Then from this one x, and then EI plus 1, and then En. Where what is this? Then x belongs to Ni, this subset of G. This implies x can be written like this. What is EI? EI is nothing but this is identity. But why do I write EI? Because they are all identity of G. All means they are not different. It is same. But why I have written E1, E2 and so on? But just to make it realize. So this is nothing but this is E, and EX, E. But just to realize that these are identity, but in I minus 1. And then again, then this is I plus 1 to I plus 1 to IN. Sorry, I plus 1 to N. So this first E belongs to N1. This belongs to N2. Baki identity is same. Yes, for all I. There is only one identity in the group, unique identity, that is E. But I have still written E1. Remember, this is not E1 is not different from E2. Both are identity. I am just writing 1, 2 to understand that this one belongs to N1, this one belongs to N2, and then this one just before X belongs to Ni minus 1. And then from Ni I have taken X, and then from Ni plus 1 I am taking identity, and again so on. I am taking identity from Nn. This is just a notation, right? So we have one notation, and let us call it 1. So let us call this one as 1. And now similarly, I can write x belongs to Nj. કેવી રીતે લખાશે Nj? So x belongs to Nj. This implies x equals to, I can write as E1, E2, and so on, Ej minus 1, and x, then Ej plus 1, and En. Again, where what is Ei? Where Ei is again E only, identity, right? But for all I, for all j, Ej. Not j is not fixed, so I should write okay. Ei is E. For all let Ek is equals to E for all k. Here also Ek equals to E for all k. Right? Yes. So now what? Now this is also an element of G. This belongs to G. And this is also an element of G. So element of G and X is same. Right? So we use the property that it is internal direct product. So the two expressions are same. That means this identity is same as this identity. That is fine. Right? E2 is same as E2. That is fine. But also here, which element is coming from Ni? This is X is coming from Ni. And here there will be somewhere Ei will be there from Ni because I and J are different. Is it clear? Since G is internal direct product. Right? X equals to Ei equals to Ej equals to E. Therefore, Ni intersection Nj equals to singleton identity. If it is not clear, raise your hand. I can repeat again. Anybody? Right? Because both are expression of X, and both expression are must be same because G has G is internal direct product. Therefore, every element has unique expression. So that means X may not have two expressions. So if both expressions are same, then that means A1 equals to B1. So this is A1. This is same as this, which is already same, no problem. Then it says that this is same as E2 is same as E2, that it is fine. But look at the ith component. It says that this is ith component, X in Ni. But look at here, what is the ith component? Here somewhere there will be ith component, which is Ei. And look at the jth component here. This belongs to, this is an element of Nj. But look at the jth component here. Somewhere there will be Ej, which is same as identity here. So that means X is same as Ei is same as Ej, and they are nothing but they are identity. Therefore, X is identity, and we are done. Right? Is it clear? Yeah. Okay. So now this is identity. Next, what is we have to prove? Next, let A belongs to Ni and P belongs to Nj, and I is not equals to J. What we have to show? This is exactly same as Chirag told. આપણે Silo theorem માં કર્યું હતું. We have to show that AB equals to BA. So this implies we can show that AB, A inverse, B inverse equals to identity. If we show this, then also we are done. Or we can show that AB, A inverse, B inverse belongs to, if we can show this, then also we are done. Ni intersection Nj, because this is anyway, this is identity. Ni intersection Nj. So can you show that AB, A inverse, B inverse is in Ni intersection Nj? Silo theorem વાળામાં ધ્યાન આપેલું હશે તો આ થઈ જશે. How do I show that AB, A inverse, this is in Ni and intersection Nj? So we know these are normal. So since Ni is normal, Anjana had given answer, I remember. Do you remember, Anjana? What should I take an element? Since Ni is normal, which element should I consider in Ni?
A inverse.
A inverse is in Ni, and then what should I multiply on the right and left?
AB, sir.
So B inverse. Right? This is in Ni because Ni is normal. So middle element is there from Ni. Sorry, middle element is from Ni, and I'm multiplying on the right and left by B inverse. So because Ni is normal, this is an element of Ni, and this implies A, B, A inverse, B inverse is in Ni because A was already, this says that A, because A was in Ni, so A inverse is also in Ni. And A is already in Ni, so I just multiply A on the left. Similarly, we can say that since Nj is normal, yes, Shilpa, answer આપો. હાથ ઉપર કર્યો હતો ને? Since nj is normal, કયો એલિમેન્ટ લેશું nj માં? શિલ્પા?
Yes, sir.
Yes, કયો એલિમેન્ટ લેશું nj માં?
A B inverse A inverse.
Yes, a b a inverse, because b is in nj, so I keep the middle element from nj, and then I take, so because it is normal, so if I multiply on the right and left by a inverse for any g b g inverse, that is in nj, and because nj is a subgroup, so if I multiply by b on the right side, b inverse, then also it is fine. So b is in nj, and so this is also in nj. Since b belongs to nj, this implies b inverse also belongs to nj, and so I multiply by b inverse, and so this element is there in ni intersection nj, and we are done. This is what we wanted to prove. Is it clear? Anybody, if this is not clear and should I repeat, then just raise your hand. Okay, so we are done. So here this completes this proof, and by the lemma we can commute, right? So by the lemma it says a b equals to ba whenever a is in ni and b is in nj, I is not equals to j. So by this we can write in this expression, then this is homomorphism, hence we can say that isomorphic to g. So external direct product is isomorphic to internal direct product. So from now onwards we call this as just direct product. We say we can use whatever expression we want. I know this is confusing because in internal direct product we take subgroups of g. In external direct product we take them independent groups. So I know this is confusing. Should we take this as a subgroup of g or not? Here also it is subgroup of g, but then we don't differentiate between a and a bar. So a cross b we had written as g, and last time we had also written as g as a bar and b bar. We don't write always a bar b bar. We write this as ab only because it is isomorphic to ab, right? So here this a is different from this a, slightly different. This a is a group, and what is this a? This a is nothing but this is a bar. A bar means it is just isomorphic, so I just write af instead of a. So I know whenever I have a here, I can express in the terms of af. But the notation we don't use different. We just use a cross b also we use, and we don't use a bar b bar. We just use ab. So when I write ab, it is understood that it is internal direct product, and a means a bar and b means b bar. They are normal subgroups of g. And when I write a cross b, then that means it has nothing to do with the subgroups. They are not subgroups of g. So this is done, and let me give one example and end this lecture. So here this implies a inverse b inverse is in ni intersection nj, which is identity, which just proved, and therefore ab equals to ba. So this is done, and let us end this by an example, very simple example of internal direct product. So let G equals to K Klein for group. Klein for group is E, A, B, C. Right? We know this. And let me check. H1 equals to EA is subgroup generated by A. A square is identity. H2 equals to EB, and H3 equals to EC. Right. So what about H1, H2? H1, H2. What is H1, H2? XY such that X belongs to H1, Y belongs to H2. So also, so I can take first E. So there will be E and E. That is first option. Then E. H1 mathi E low. H2 mathi I take B. Then option is AE. Right? I taking H1 A from H1 and E from H2. And then last one is AB, all different combinations. So what is this? So EE is E, EB is B, AE is A, and what is AB? AB equals to C, plain for group. We know what is this AB. AB equals to C equals to BA. Right? So H1, H2 is same as, this is same as H2, H1. And this is nothing but it is my G. It is plain for group. So that there thus H1, H2, G equals to H1, H2 is internal direct product. Oh, it is not internal direct product. I have to verify one more condition. Yes, this is nothing. I have verified only one condition. First condition, which is G equals to H1, H2. आटलू ज verify करूँ. अभी तक तो इतना ही हुआ. Second condition is there. What is there? Unique expression. Yes. Can you say that it has unique expression? Every element must have unique expression. So if I want to write E ने कई રીતે લખા છે? If I want to write E in terms of H1, H2, how can I write E? So let us write unique expression. E ne as an element of H1 and H2. There is only one way, right? E times E. Then what about A as an element of H1 and H2? A, there is only one way. I can write A from H1, E from H2. What about B? B also there is one way. How do I write it?
B into E.
Yeah, E into B, not B into E. First element is coming from H1.
Okay.
Yes, first element is coming from H1, so E into B. And what about C?
AB. A into
Yeah,
B.
C, A into B. Yes, so every element has unique expression. Yeah, so that is done. And yeah, one question was this: what about the converse? Of this lemma. Do you think this is true? I want to finish this topic right now, so if you don't mind, I would like to extend 2-3 minutes more, maybe 4-5 minutes if you are not tired. And if you want to do it on your own, then I can ask you to do it. Just examples here, since we are on the same note, so I would like to extend. Chate karu hai, so if you want to think about converse yourself, then you can do it yourself also. Then also we can end up the meeting right now, because then we will not start with the next topic. Karu extend just 5 more minutes.
Yes, sir.
હા સર કરી દો.
Okay. કોઈને ના હોય એવું છે? So I don't want to repeat it. Either take it as homework or do it right now. So, and because this is the last class, so I can extend. Do have the liberty. I know તમારો પહેલો class પણ extend થયો તો 11:30. I understand કે તમે 11:30 થી busy છો, but then I would like to give you as homework what about the converse of this lemma, which I usually give in seminar. But since I have already given one example in the notes, I know તમે જાતે નથી કરવાનું, લખી લેવાનું છે. So let me discuss it right here itself. Okay, what do you think about the converse of lemma? If suppose G equals to product of N1, N2, N, and if Ni intersection N J is identity for all I not equals to J. So here is a question. Those who want to leave can leave, no problem. Anyway, I'm not taking attendance. So this is always true for my online class, offline class. Come anytime, go anytime. Yes, converse. That is, if G equals to N1, N2, Nn, let us say G can be written as product of this, where Ni are normal subgroups, where Ni are normal subgroups. such that Ni intersection Nj, this is identity whenever I is not equals to j. Is it true that G is internal direct product? If you answer yes or no, you raise your hand. Either yes or no, whatever idea if you have. I'm not asking તમારી પાસે whatever you answer you have should be correct. I'm asking about idea. Is it true that I have already given one condition? Yeah, one condition is already given. G is internal direct product. Normal subgroups are also given. So they are normal subgroups. First condition is already satisfied. This is already satisfied. Second condition, unique expression value, that is you have to check. Anybody, any idea? Any feeling? Yes or no? હા શિલ્પા, yes.
હા સર થશે એવું લાગે છે કેમ
થશે
કે
એવું લાગે છે કે
હા આઈડેન્ટિટી એક જ કોમન આવે છે ને બધાયમાં તો યુનિક એક્સપ્રેશન મળશે.
Okay, yes. And first condition to already satisfied. The normal subgroups is given, and G equals to product of that. That is also given. Only thing you have to verify that every element has unique expression. And what she says is identity intersection is identity, so the expression must be unique. Then we should be able to prove that expression is unique, and if not, we should be able to give a counter example. So she thinks yes. Anybody else thinks yes, or otherwise? No લાગતું હોય તો you can raise hand. કાંઈ ના લાગતું હોય તો એમને બેસો. અને બહુ મગજમાં લાગતું હોય તો you can leave the meeting. Yes, Chirag?
સર એ ઇન્ટરસેક્શન આઈડેન્ટિટી હશે તો થશે એવું લાગે છે અને જો ના હોય તો કદાચ
Intersection
નહીં થાય.
identity આપેલું. Yes.
ઓકે તો થશે એવું લાગે છે.
થશે એવું લાગે. હું તમને એક એક્સરસાઇઝ આપું. અહીંયા આપણે whatever I have written એટલે મેં સ્ક્રીન ઉપર આવું રાખેલું છે. Instead of H1 H2, take the product of all of them. અહીંયા મેં કેવું લીધું? What I have taken? H1 H2, right? What I'm asking you to try this. All of you, if you have pen and paper and if you have energy left with you, try this. Try product of H1, H2, and H3. Yeah, let me write this again. What is G? G is a claim for group E, A, B, C, which is claim for group. H1 is the cyclic subgroup generated by A. A has order, we know A square, B square, C square is identity. AB equals to B, A equals to C, AC equals to C, B equals to A, B, and so on. So this is nothing but EA. H2 is the cyclic subgroup generated by B. So E, B square is identity, and H3 is C. So C square is identity. Yeah. So this is H1, H2, and now compute this H1, H2, H3. So you will have like this X, Y, Z, which will be difficult because you will have so many combinations. X in H1, and then Y in H2, and Z in H3. Whether it is, of course, it is a subset of G or equals to G. That is what we want to say. If you can find out equals to G, easier way is not to try all this combination. Don't try all combinations X, Y, Z. Just say that all these elements can be written in some combination like this. Suppose I want to show that this is equals to G. In fact, how do I show that it is equals to G? Can I write E like this? Identity લખવું તો કેવી રીતે લખાશે? How do I write E? Can I say that E belongs to H1, H2, H3? હા કેવી રીતે લખાશે? E belongs to H1, H2, H3. As yes, we can write E equals to E, E, E. All of them have E. Yes, so I can write like this. First element coming from H1. This is coming from H2 and this is coming from H3. So if we can show all four elements are there in this form, then we can show that this is equals to G. What about A? Can I say that A belongs to H1, H2, H3? Yeah, so this belongs to H1, H2, H3 because A equals to, I can write as A, E, E. So A is in H1, E is in H2, and again E is in H3. What about B? Can I say that B belongs to H1, H2, H3?
Yes.
Yeah, it is there. Why?
E,
Why?
B.
Because
Yes,
B we
sir.
can write E, B, and E. Okay, B is in H2, so middle one. And similarly, C also is in H1, H2, H3. Because C we can write as E, E, C. Right? C is in H3. Okay, so therefore all the four elements are there in H1, H2, H3. This is already subset. And now we have shown that all elements of G are in this one. So this is all subset. So this is equals to this, right? So this is subset, and we have shown that this is also subset. So therefore, what we can say that H1, H2, H3 equals to G. Here we have written G equals to, this is an internal direct product of H1, H2. So can I write, the question is, can we say?
નો લખાય સર.
એક જ મિનિટ ઉભો ધીમે ધીમે એટલે ઉતાવળ લખવા તો દે. હું તો કેન લખું છું અહીંયા, પ્રશ્ન પૂછું, પ્રશ્ન લખાય ને જો લખાય લાલ પેનથી રોકવું હોય તો રોકી. Can we say that G is internal direct product of H1, H2, H3? Question mark. Question mark I can write. Of course, the answer is yes or no, and that Amit is saying no. And also note here what we have. We have some other conditions also. What is H1 intersection H2? What is the intersection of these two? What is the intersection of these two? And what is the intersection of first and third? What is intersection? Yes, we have H1 intersection H2. What is this? This is only identity. Yes, H1 has A, H2 does not have A. This has B, H2 does not have B. So that is identity. What about H1 intersection H3 is also identity. And what about H2 intersection H3? That is also identity. So intersection of all this mutually, yeah, they are not, I cannot say disjoint. Disjoint not identity, but they are trivial, pairwise trivial. That means the intersection is trivial. Okay, so intersection is trivial and G equals to product. All are normal subgroups. There is no question about normal. Yeah, all are normal because G is abelian. So every subgroup is normal. All are subgroups. There is no question about subgroups, normal subgroups. H equals to H1, G equals to H1, H2, H3 because every element is there in this product, and the product is of course subset of G. So they are equal. So finally they are equal. Now the question is this. Amit, શું કામ નહીં લખાય?
સર એમાં H1 માંથી E અને H2 H3 માંથી B અને C લેશું તોય તે એ જ મળશે ને, યુનિકલી રિપ્રેઝન્ટ નહીં થાય.
What he is saying, that if I can write A also as some other expression of A. What is that expression of A?
E, B and C.
He is taking E from H1, which is different because here we have taken A from H1. Right? Here we have taken A from H1. Now he is taking B from H2. B belongs to H2, yes. And C belongs to H3. So here we have taken H2, we have taken E, and H3 also we have taken E. But what is this EBC? That will be, what is BC? BC is nothing but BC is A. And so this is EA, and so it is equals to A. So A has two different expressions, right? A has two different expressions, AEE and EBC. What about identity? Can we say that identity has two different expressions? Of course, ek mali jaye na, we are done. We are done. See, what is the second condition of internal direct product? What is the second condition? This was the definition. Let me highlight that. Go to the yes. This is the first condition, and every G can be uniquely written as this. So this was the second condition. That every G can be uniquely written as, all G and G can be uniquely written as this. Yeah, so this was, there are two conditions. This was the first condition, and this was, yes, this was the second condition. And here we do not have any, and one element which has two different expressions. We don't have unique expression for A. A can be written as A, E, E, where A is in H1, E and E are in H2, H3. Similarly, E in H1, B and C. B in H2, C is in H3, so BC is A, so EA is A, so it has two different expressions. Similarly, all other elements will have, you see, this has two different expressions. E can is there any other way to write? By the way, one is
A,
sufficient.
B, C.
Yeah, so I can write A, B, C. AB is what? AB is C.
A, B is equal
Then
to
C. So C square. C square is identity. Yes. AB is C, or you can write BC is A, and then A square. Right. So what is the relation here? AB equals to C equals to BA. AC equals to B equals to CA. And BC equals to A equals to CB. So yeah, this also has two different, every element has expression. One is enough. We have found one, so find other expression for this. Right? Some you can always find. Every element has two different expressions, but one is enough. Once you have ek mali gyo na, then we are done. So this is not possible. No. Counter example is above. Yes, Prabhat, બીજું કઈ કેવું હતું? બીજા expression દેવા હતા? Find expression of this one.
Unique no.
Yeah. Example. Oh, not counter example. So yeah, counter example of for above lemma. For converse of above lemma. Okay, so this was your exercise, which I have completed. I've given one example. You can find some other example like this. Think of some example if you can find. Do let me know. Okay, thank you for patiently listening. I know you are all tired, but then this topic is over, so I do not want to go to just simply waste next 15 minutes for this, revisiting this, especially when you are not prepared, revised enough to this difficulty. Okay, so let me stop the recording and then screen sharing. If you have any doubts, you can stay, otherwise you can leave.